Thanks everyone. Welcome to the course of Machine Learning Application in Manufacturing Engineering. I am Dr. Salman Masroor Khan and I am lecturer at the Department of Mechanical Engineering in Balochistan, UAT Khuzdar. This course is actually a part of the Erasmus plus CBHE program, implementation of digital transformation practices through the capacity building of occupational and industrial stakeholders in Pakistan and Malaysia. We will go through some table of contents. I will briefly introduce and give some fundamentals of machine learning, some overview of machine learning, and then we have to understand some key terminologies of machine learning. We will have a look on manufacturing, what is manufacturing, and what are the types of manufacturing, and how machine learning can be transformative to the manufacturing. And then we will have a looks on the applications of machine learning in manufacturing. Some hands-on practice I will be giving on you people for regarding the welding plant. So basically, first we will understand the ecosystem of AI and why I'm giving this introduction of AI is basically AI is actually the application of intelligence to the machine so that the machine can learn and act according to the human behavior. So, in order to achieve that artificial intelligence, we have to provide machine some patterns of data so that it can understand that pattern of data, so that it can behave and act according to the humans. So that pattern of data is provided by the help of machine learning. That machine learning I will discuss in the later slides that it is supervised and unsupervised, and the modified form of machine learning is deep learning. And the more advanced form of deep learning is generative AI. And with the help of generative AI, we have large language models, and with the combination of language models and generative AI results in ChatGPT, which we people use in our daily life for various tasks. So, what is machine learning? Machine learning is basically a field of artificial intelligence where algorithms are trained based on the patterns of data given to them. That data can be in the form of text, that data can be in the form of audios, videos, uh, and our general behavior. So, it learns the pattern, and then after learning that pattern it predicts and decides what has to be done, and this is done without being explicitly programmed for each and every task. We don't need to program it each and every time. Once we will have to feed the data, then the machine learns the data, and we also provide some raw form data. It separates the data, and then the clean data is fed to the machine, and then it learns the data. Based on the learning, it predicts and decides what has to be done. So this is the uh, basic machine learning process. We provide data. We actually collect data first, and after collecting the data, we prepare data. In the preparation of data, we actually uh, decide what has to be done, what has to be removed. If there are some missing links, we have to uh, uh, include the divided links. And then the data is actually collected from various databases. Some sensor data is also there. There are text, images, files, and that data is clean, transformed, normalized, and structured so that algorithm can process it. So this is the data preparation process. Then there is data analysis, where various patterns and correlations and distributions are studied to understand the data. And this step helps in selecting suitable algorithm and features that adjust parameter to minimize the error. So this is the uh, data analysis and model training phase, where the algorithm learns and trains based on the data we provide. So basically, first the data is prepared, and then it is analyzed, and then the algorithm that we are going to train is based on the data quality that we have provided to them. After the training, during the training, the model learns the relationship between input and outputs by adjusting parameters to minimize error. Once the data is learned, then the model is uh, able to predict. The trained model is used on new unseen data to make predictions. That is, we can also say that by the predictions can be classifying some images, we can forecast some sales, we can detect anomalies in the machine or in the structure. So, after prediction, the last stage is decision making, where we predict the the interpretations and applied the real world problems. Output supports or automates decisions such as medical diagnosis, credit scoring, or recommendation systems. This is actually the machine learning phase where I will discuss this unsupervised and supervised data sets. We uh, collect various kind of data sets, and then we provide it to the algorithm where features are extracted. After the extraction of features in the data, the algorithm learns that features, that pattern, that behavior of the data. And after learning and understanding the patterns and features of the data, the algorithm is being able to group objects based on the data it has learned. Once the data is learned and gathered, the system can be able to predict various kind of unidentified data. So this machine learning system explains, this slide explains the process of machine learning. But here I would like to explain the evolution of industrial revolutions. We need to understand where machine learning lies and how the AI systems can be more helpful in the future or in the coming industrial revolution. So we started with the mechanization where steam engines were developed, some textile machinery is used, and hydraulic power in the form of steam or in the form of fluid was used. There was transition from manual systems to mechanical systems. And then these mechanical systems require electricity for the mass production, that is Industry 2.0. In the second revolution, the industry was developed based on the electricity it has got. So mass production was being able to achieve, and due to mass production, we have large scale manufacturers. So after large scale manufacturing, automation was required. So in the industry 3.0, we see that there is some kind of automation where PLCs and some CNC systems, computerized numerical control systems, were being developed in the Industry 3.0. And uh, after automation, we have to record the data so that we can decide based on the data from various systems that how we can optimize the performance of the system. That is being achieved in Industry 4.0, where smart connected systems, IoT, and cyber physical systems were integrated, and these factories were intelligent. Predictive maintenance was achieved, and some digital twins. I will explain this in the later slides what is digital twins and predictive maintenance is. So, intelligent factories were developed. Once the intelligent factories were developed, we have Industrial Revolution 5.0, where we can collaborate with the intelligent machines that are robots. So these robots can be able to decide based on the data it is gathering from the IoT systems and various sensors. After understanding what is machine learning and the industrial revolution, I would like to explain what is manufacturing, because we have application of machine learning in manufacturing. So, what is manufacturing processes? Manufacturing process is actually the transformation of raw materials into some valuable goods that can be used for various kind of systems, various kind of tasks. Uh, but here we understand the concept of use of labor, machinery, tools, and chemical and biological processes to achieve manufacturing processes. So, manufacturing process is divided into three forms. One is subtractive manufacturing, where the raw material is subtracted and developed into shape. That can be done through lathe machine, that can be done through milling and grinding machines. So that is the one form of subtractive manufacturing. The second form of manufacturing is additive manufacturing, where we add material so that we can achieve the shape that has to be developed. That is additive manufacturing. The example of additive manufacturing is our 3D printers. We have polylactic acid based, PLA based 3D printers, that is FDM 3D printers, and we have uh, selective laser sintering printers. So these are all examples of additive manufacturing. Then we have the third form of manufacturing, that is formative manufacturing. So formative manufacturing is actually we make the fluid, and then once the fluid is entered in the in some mold, then hot air or some hot hot mold is injected in the mold, and then that mold is given the material gave the shape, given to the shape of mold. So this is a form of formative manufacturing, where we use injection molding or some extrusion process to achieve formative manufacturing. Now, after understanding what is machine learning, what is the industrial revolution, we come to the slide of understanding the key terminologies in manufacturing. Sorry, in machine learning. So, in machine learning, we have the data, that is the raw information from the various sources, like we have sensor readings, we have some images, we have some videos, some measurements. So, we provide that data to the algorithm. The algorithm understands the pattern or behavior of the system. The algorithm is basically a mathematical system or mathematical equations that learns the pattern of the data, so that it can provide the predictions based on the pattern of the data. So that pattern of the data is learned through the algorithm, and that is called training. And after doing the training, the model is provided some unseen data so that it can do the predictions, and that predictions can be utilized to achieve artificial intelligence. This is another slide that shows the connection of system from various things like data. We have extraction of features. The features are provided to the model. The model gets trained based on the features or data patterns of the data that is being given. And after the data is being trained, the algorithm provides prediction. There are three types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. We will see each and every slide one by one. So what supervised learning is? Supervised machine learning is actually the based on the data that we provide to them. The data that we provide to them is a labeled data, and then we ask machine to understand that labeled data so that it can classify some uh, labeled data. And when we give the data to the system, the unknown data, so that it can understand the behavior. One thing that we have to understand is how the algorithm works. The algorithm is given both the features, some independent variables, and expected target outputs. So, based on these two variables, the classification is done, and the classification model attempts to predict the category or class level of the given input based on its features. That can be some categorization of email as spam or not spam. So basically, the machine supervised machine learning attempts to classify the data in various forms. The second is actually parameter is regression. So the main objective of regression method is to discover a relationship between input variables that are features or and the target values. So target values are actually the outputs that it has to be predict. That is predicting house prices based on the features like location, size, number of bedrooms. So the data is used for training include both the input feature and the desired outputs or labels for each data point. So the model learns the relationship between features and labels so that it can accurately predict the output for the new unlabeled data. This is the model of the supervised machine learning. Various sources of data is being provided to the training data. Once the training is done, then training is done for the model. Then the model is deployed for the production or predictions. Sorry, I need to give it prediction. And then once the predictions are done, we need to uh, update the data. We also need to understand that before testing, we need to evaluate the model that it is providing the correct data or there is some discrepancy in the data. So that's done based on the data that is distributed in three forms, and that is training data, validation data, and testing data. So we also validate the results after testing that the data is providing correct results or there is some kind of discrepancy in the model. So we need to evaluate the model during prediction. We can also see the pictorial view of this thing of the supervised machine learning, like this regression that what will be the temperature for tomorrow. We provide some raw information and then it predicts the temperature of the uh, future predictions. It can give various predictions. Similarly, the classification can be done like hot and cold. So we can provide various temperatures and then we can ask the supervised machine learning algorithm that uh, the future day can be cold or hot. So it can also classify the based on the data it has obtained. Now, the second form is neural networks. The neural networks is actually we here I would like to introduce another concept for training, another tool for training, that is neural networks. They work like human brain. In human brain, there are various neurons, and these neurons are actually connected with the central layer. When we see things, or human brain when process the data, it actually structures the data based on the features that it has seen. So basically, the relationship of machine learning uh, with the neural networks is actually, it is a learning paradigm where we train model using labeled data, and then the neural networks are one of the many algorithms that can perform machine learning. We can understand it like a learning approach that can identifies various features based on the neurons. It can decide that the given image can be cat or dog or something else. So this is the advantage of using neural networks. But the usage of only neural networks are not enough for the identification and classification. We have to use deep neural networks. So, in classical neural networks or convolutional neural network, there is only one layer, that is a single layer neural networks. And when we understand, when we connect it with various layers, where various input layers, so that various input layers are being used for extracting the deep information within the image or within the data. So, by the usage of deep neural networks, we can extract the deep information, deep patterns that are integrated, that are present in uh, the the unlabeled or unstructured data. So I've explained each and everything, that what is a hidden layer, and how we add weights, what is the activation layer, and there are some we have some terminologies that has to be understood. We can You can have a look on each and every part of neural network layer, explaining what are the parameters. Since we are not concerned about the training of data in deep depth, so I have given this information in my slides. You can study these. Then we have second form of uh, machine learning, that is unsupervised learning. And this unsupervised learning is actually, we provide the data and the machine learns based on the uh, unlabeled data. It finds patterns, it finds some anomalies in the unlabeled data, and then it understands that data by understanding the features and patterns, and then it has to classify, it has to uh, understand that how the data is being provided to it, and then it based on the unstructured data, it actually classified structures the data based on the features. So that can be this unsupervised learning can be used for anomaly detection, for identifying defects or unusual system behavior. We can use it for monitoring to understand operational phases. We can also we can also implement this unsupervised machine learning approach for predictive maintenance, to forecast equipment issues. Some exploratory data analysis is also being used to identify hidden relationships for continuous improvements. Then we have a reinforcement learning, and you can think it as training a pet. When your dog does a trick correctly, you give it a treat. Over time, it learns to repeat the trick for more treats. In reinforcement learning, the machine learns by trial and error, receiving rewards for correct actions and penalties for the mistake. This type of learning is often used in gaming AI, where the algorithm learns the best strategies by playing the game over and over, improving each round. Reinforcement learning revolves around the idea that an agent, that is the learner or decision maker, interacts with the environment to achieve a goal. The agent performs action and receive feedback to optimize its decision making over time. So, what is an agent? Agent is the decision maker that perform action. The environment, that is actually the world or the system from which the agent is interacting. The state, the situation or condition the agent is currently in. And then the two concepts, that is action and reward. The action, the possible move or decision the agent can make. So, based on the decision or the action, it has to be rewarded. So, the reward is actually a feedback from the environment, so that it can learn that it has taken the correct decision or not. This is the comparison of supervised, unsupervised, and machine learning approaches, and where we can apply it based on the type of data and training and how it can be used. And there are some famous algorithms that can be applied so that we can achieve various actions or various tasks using machine learning. Some common machine learning algorithms for various tasks are also mentioned here. Now, I would like to explain the application of machine learning uh, in manufacturing. We have product design and development. We have smart manufacturing for industry 4.0, and some robotics and automation is being present there. We When the systems when there is manufacturing, we have to ensure that there should be supply chain and logistics and predictive maintenance, because the machinery is continuously being used, so it will be developing various kinds of error and operations and production and operations. So, the key benefits of machine learning application in manufacturing is reduction in the downtime and maintenance cost. Downtime is actually the time where machinery is not working. So, this is the advantage, and we have improved product and consistency, because uh, continuously the product will be produced and that product does not have any discrepancy. We also have some enhanced operational accuracy. uh, we can use the resources in a better form. We have some data-driven decision-making processes, and the automation can be scalable, so that we can achieve some uh, efficient processes while you producing various products. I have also given some applications while machinery is being used. We have basically four domains, that is product, that product is being developed through process, and that process is actually uh, basically machines and integration of machine, that is systems. So we can also use machine learning in various domains like quality improvement. We have optimization in process planning and adaptive control. We have adaptive compensation of errors and adaptive production planning. So, machine learning can be used in various forms of manufacturing. I have given the correlation of machine learning, how machine learning is transformative to manufacturing. And this slide shows the correlation of machine learning, how the machine learning is transformative for manufacturing, because it acts as a central intelligence that learns from production data and supports better decision. It enables manufacturer to move from experience based operation to data driven optimization. This improves the productivity and it also reduce the cost and enhancing the quality. By predicting machine failures, optimizing process, and ensuring consistency in product quality, machine learning continuously improve manufacturing systems and accelerates the innovation. Uh, we can also apply machine learning in smart industry by the help of digital twins. We can also replicate the actual system with a digital system so that we can understand that where can possibility of errors by these possibility of errors can be reduced by the help of IoT integration and real-time analytics. This is achieved by the help of some cyber physical system and edge computing. And by the help of integration of these things, we can achieve smart factory systems. This product design and development cycle is actually shown in this slide, and this is an iterative life cycle that moves from identifying market needs to detailed design, prototyping, testing, and validation. Machine learning supports this life cycle by acting as a data driven decision support tool at every stage. Machine learning helps engineers to understand market needs by analyzing customer behavior, needs, and requirements. It also generate and evaluate the design concept based on the data driven pattern it has identified. Then it predicts the performance early during embodiment design using data instead of repeated simulations. It reduces prototyping efforts through virtual testing and failure predictions. It also improves design faster by learning from test and validation data. It also ensures manufacturability and cost effectiveness during detailed design. The key idea is that machine learning does not replace engineering judgment. Instead, it accelerates this design decision, reduce trial and error, enable continuous improvement by learning from data across the entire product life cycle. Machine learning is not a replacement for engineering judgment. Machine learning is actually a decision support system throughout the life cycle.